Okay, we'll go ahead and get started. And yeah, I hope you guys are doing well. All right, so on Monday, we introduced the concept of a class in Python. And we've been working with this time class. And right now, we just initialize a class. Well, we define a class by kind of just saying class time. And then, and so far, our class definition has been pretty empty. All we've put in so far is a doc string, and that's all we have right now. But once we have the class definition, we can add attributes kind of in this ad hoc manner. We just take the, we create an instance of the time. We do .hour, .minute, .second. We assign values or to that, and that kind of fills in some values or attributes in the thing. And what we've done so far is we have we've written a few functions that that work with these time objects. Okay, and so right now we have this increment time function, which kind of takes a time, an instance of the time class object. We give it the number of seconds in some an integer form, and then it adds them and it does it properly. Okay, and this is kind of where we left off on Monday. And I wanted to kind of continue on talking about object-oriented programming in Python. Okay, and so we looked at prototype and patch as a programming strategy where you start off with something simple, and then you kind of, when you encounter errors such as we added 3 minutes and it added 1 minute to the number 180 seconds, and what it did was it added 1 minute to the minute, but then it added like 120 to the number of seconds, and we had to kind of patch that or fix that function so it works properly. Okay. One drawback is that the incremental corrections can end up creating code that's unnecessarily complicated, right? And so another is to kind of take this designed approach where we say, you know what, let's think about these things first, and then design functions and programs around kind of this central core idea. Okay, and so this is a bit of an alternative, and what we're going to do here is we're going to take a time object and we're going to convert the time object into seconds. Okay, and we're going to convert all of our times into the number of seconds from midnight. And then, you can kind of just add those integers directly, and then we'll have to have a function that takes the number of seconds from midnight and converts it back into a time. So it's a little bit of a contrast from taking the time, adding the number of seconds, and then doing a whole bunch of kind of integer division to come back with the time. This time we're going to kind of convert everything into the number of seconds from midnight. And then we'll have a function that takes the number of seconds from midnight and converts it back into time. So if we have something in time, what we're going to do is we're going to do time.hour, multiply it by 60, and we're going to add that to the number of minutes in the time. That will be the minutes. We'll take the minutes, multiply it by 60, add that to the number of seconds, and that's going to be how many seconds have passed since midnight. Okay, and then what we'll do is we have a function that converts it back, which takes the number of seconds and is going to turn it back into time. So we're going to initialize a blank time class instance of the time class right now, which is totally empty. And then we're going to say, all right, take the number of seconds, do integer division, get back the number of minutes, get back the number of seconds, and we'll take the seconds and apply that to time.second. And then we'll take the number of minutes and we'll do integer division, and then that will become the hour in the time instance and the minute in the time instance. All right, so here's just an example. We can create an instance of time, saying 9:45 in the morning. We'll test that out, print it out, and it says 9:45. We can convert that into the number of seconds, okay? And, we can see, every 60 minutes, 60 seconds is a minute. So we can do, 45 times 60, that's 2,700, okay? And then what we have is 9 times 60. We have 540 times 60, 540 minutes, 32,400 seconds plus 2,700 will be 3510. So that's how many seconds 9:45 is. And then if we convert 3,510 seconds back into a time, that will create a time class object, and then we can do print time, and indeed we get 9:45 back. So that's good. That's good. Okay. And then so now what we can do is we can take two times, time 1 and time 2. We're going to convert both of those into integers, into the number of seconds. We'll add those together. And then what we'll do is we convert the seconds back into a time, integer number of seconds back into a time, and that's what we'll return. Okay, and so this works as a function here. Does that kind of make sense as an approach here? I hope. Okay, so what we can do is we can now create functions that belong to the class. Okay, we can create functions that belong to the class. And so these will be our methods. Okay, so the methods are the same as a function, except the function definition is defined inside the class definition. Okay, and then when you call a function or call a method, you're going to use the dot notation. Okay, so again, here is our time class. Oops, so this is our time class. Right now, we've defined it as just class time. We have nothing inside our class definition. All we have is a doc string, okay, which really does nothing as far as functionality goes. Okay, all we have is a blank class definition called time. All we've done is this. And, we have a couple of functions. We have a function that takes the time, and it takes the hour, minute, and second, but that's not even part of the class definition. We're just assuming that we're adhering to this standard. If somebody else comes along and decides to just add whatever they want to the class definition, it's not going to break the code, but this function's not going to work either. Okay, so far our functions work because we've been adhering to the properties of what we believe to be a good time class object. Okay, and so this is how it's been working so far. Is we say, all right, here's our start time, 9:45, and then when we print it out, it comes out as 9:45 here, right? So this is what we have. Oh, by the way, if you want to have 2 digits and things like that, which I think was an issue for a problem maybe a couple homework back, if you want the leading zeros and stuff, this is how you would do it. Okay. All right. So now all I'm doing is I'm taking this function, define print time. Okay. And I'm going to take this and I'm going to put it inside the class definition of time. Okay. So here I'm going to say class time. And then I put the definition of print time. And now this thing, print time, is a method that belongs to time. Okay. And now that I have something here, I technically don't even need to include the doc string. The doc string I put in here just so that I don't get an error when I define a class, because Python's expecting something to be there after I put in this colon here. Okay. Now it's probably good to still include the doc string, but I haven't. Okay. All right. So now we have a method called print time that belongs to the class definition time. Okay. And so now I'm going to create another instance of time, and I have to kind of recreate the instances of time because because this instance back here was created under this definition of time, which doesn't have the method print time. And now that I've redefined the class definition of capital T time, this instance of time start will take on this definition. So we redefine what a time class object is, and this is going to have it. Okay. And so now we have start, and we've added our attributes ourselves. Again, we're assuming we're adhering to some kind of good definition here. Okay. And to call the method now, we take the we can call it this way. We can take the class definition capital T time and call the method name print time and pass it the object start. Okay, so this is one way to do it. Okay, this is not the common way. This is not the common way. The most common way to call the method is that this instance start has the print time method, and we would just call start.printtime, put in parentheses with nothing inside, and it's going to print out the time there. Oops. Okay, and so when you do this, okay, when you call the method from the object itself, the object is known to be the subject of the method, right? And so the subject of the method will get passed as the first argument. Okay, it's going to just kind of get passed as the first argument. So here it's going to take print time. You know, as far as our definition goes, it says print time. Okay, when we do this, it's going to pass itself into that first argument, and that's how it prints out. Okay, I just kind of want to pause here and make sure everybody's good with how the method works. Okay, as far as calling a method, all we've done is really we just took these functions that have existed before, and we just moved the definition of the function into the definition of the class. And now that we've done that, we can call the function like this. Okay, rather than we used to have to do like print time start. Okay, and you can still kind of use that form here by taking the class definition dot print time and then putting in that object. That works. It's less common. This is probably the most common form here. Okay, let me go ahead and give you your first view quiz answer for today. First view quiz answer for today is B. B as in bear. B as in bear is your first view quiz answer. Okay. All right. So this is one thing that you have to kind of get used to, is that when you look at class definitions, when you read code where there have been objects and things defined, you're going to see this word self appear. Okay, and this is kind of a convention. It's not like a rule that everything has to follow this, but by convention, the first argument of a method is called self. Okay, so over here, back when we defined print time, okay, we've put in the word here time, and the code works. But in general, when we define it, we're going to be putting in self. Okay, we're going to be putting in self. So when we define the class definition time, in general, the way we're going to do this is we're going to put in self as the argument. Okay, so it's going to be print time. The method print time is going to be self, and then we do self.hour, self.minute, self.second. Okay, this is generally the convention. It's not a rule. Python will work, as we saw back here when we defined the class definition. You don't have to use the word self here, but it's generally good practice. That's the convention. People will have an easier time understanding your code if you follow the convention and use the word self here. Okay, so it's going to be print time self, and then we're going to call everything self hour, self.minute, self.second. Okay, so this is how we're going to do it. So, and the idea here is that, you create an instance of whatever class it is. In this case, we're going to create an instance of the time class. And within that instance, there is a value. There's an attribute hour, an attribute minute, an attribute second, and those all belong to that instance of the class. And so therefore you're asking, what is the hour, minute, and second attributes of yourself? You're kind of asking the object, tell me these things about yourself. What is your hour? What is your minute? What is your second? Things like that, right? If we were talking to you as a person, I would ask you, what is your age? And you'd say, myself, my age is something. This is an attribute of you, an instance of a human, right? And so, so we have that, okay? And so keeping that in mind, what we're going to do is we're going to add this other method, which will take the values of the time, okay, the hour and the minute stored within itself, and we're going to turn that into the number of seconds after midnight. Okay, so this is kind of the function that we've defined earlier, and we're going to take the time and convert it to an integer number, which is going to be the number of seconds after midnight. And so we're going to take the attributes, the hour of itself and the minute of itself. We're going to take the number of hours and multiply by 60 and add it to the number of minutes. And then we'll take those total number of minutes after midnight, multiply that by 60 and add the number of seconds. And that will be the total number of seconds after midnight. Okay. Is that all right? And again, we've redefined what this definition of the class time is. And so we're going to have to create new instances of the time object. Okay, so we're going to do start here again. We create an instance of the time. And so, this instance will have these two methods, print time and time to int. And then we're going to add these attributes, start.hour, start.minute, start.second. We're still sticking with 9:45 in the morning here. Okay, and so I can call, the method start.printtime, which gives me 9:45. And I can do start.time-to-int, right? Time to int, again, it passes itself, okay? It's going to take itself, it's going to pass it into the function here, and then it's going to pull out all of these attributes. Okay. I hope this is okay with everybody. Okay. A lot of you have your cameras off today, so it's difficult to read the room. Okay, but all right, thanks for your thumbs up there. Okay. All right, so what we're going to do is we're going to also, we've got to convert the number of seconds into a time, right? So we need that function, and this one, this function, number of seconds into time, it can't be made as a method of the time object because the argument of this function is an integer value of seconds, right? So this is not something that we can kind of invoke the method on. So unfortunately, we can't put this in as a method of the time object because the purpose is to take the number of seconds, which is just some integer, and convert it into a time object, right? And so if we define this inside the class definition of time, it's a little bit silly because the purpose of this function is to create a time object. It's already a time object. So it doesn't make sense to put this inside the class definition of time. So this is just kind of going to be a helper function that exists outside. We've already seen this definition earlier today, so I'm not going to dwell too much time on it. But again, this one has to exist outside of the class definition just because what it's going to do is it's going to return an instance of time, right? So it initiates an instance of the time class, and then it returns that object there. Okay. I'm getting that. What's that sensation? I forget, or that phenomenon where you see a word written so many times that it like loses its meaning, and now you're just like questioning whether I've seen the word time so many times now that it's like, does that actually have a meaning? Okay, So we're going to continue developing this time class. So we've already seen print time, we've already seen time to int, and now we're going to define another function called, or another method inside the time class called increment. And we're going to just take itself, okay? And we're going to take on some number of seconds. So we're going to take the current time and we're going to add on some number of seconds, okay? And so what we'll do is we call increment. So we're going to take the self, we're going to call time to int. This is going to convert the current time of itself into some integer. And we're going to do add that on to whatever number of seconds we have here, right? And so the addition is commutative, so it doesn't matter what order I have. So this could be something like 20 seconds. We're going to take our current time, add that to 20 seconds. So the total number of seconds is whatever this was plus 20. And then we have to call the external function, take the integer and return back a time object there, okay? And so this, we're going to take that and return whatever total number of seconds is, return that into a time, okay? So here again, we redefine the object, the instance of class time. So we have 9:45. And then what we'll do is we're going to add 1,337 seconds. Okay, so 1337 divided by 60 is 22 minutes. And what did I do? Oh, okay, yeah, 22 minutes, right? And then so, sorry, 22 times 60 is this, minus 1337, 22 minutes and 17 seconds. So we're going to take 9:45, add 22 minutes. That takes me to 10:07 and 17 seconds. So I have 10:07 and 17 seconds. Okay, so I have the end time is going to be start plus increment. So here, end is going to be start plus increment. So the start time remains unchanged. This is returning an entire new object here. Okay, and this new object is going to be a time object because we've defined this function int to time, which returns an instance of the time object. Is this okay? I don't know if I'm going too fast here as far as what's happening. And so when we call start.increment 1337, this is returning a new instance of this, whatever this is, which is an instance of time. And that's going to be my end time. And then when I say print that out, end.print time, I got 10:07:17. Okay. If we do something like this, okay? So when you call a method from an object, right? So here we do start.increment, and I do something like 1337, 460, okay? The object itself is always passed in as the first argument of the method. So here, the argument of increment is self and seconds. And when you do start.increment, okay, start is going to get passed as the first object here. So start becomes, it's going to be increment, take the start object and add 1332 to as the seconds, okay? And so what it's saying here is when I do start.increment, it sees three arguments. It sees start going in as kind of the first argument, the self argument. And then it sees 1337 as the number of seconds. And then it sees 460 and it doesn't know what to do with that. And so it gives you an error. It says the increment takes in two positional arguments, which would be self and the number of seconds, but it's seeing three. It's seeing start as the self, 1337 and 460. When you see this error the first time, it's a little bit confusing because you're saying like, I only see two arguments here and it's saying three were given. And again, when you have, when you call methods, the object itself is passed as the first argument. Okay, so that's important to keep in mind. And that's why anytime you read someone's code for kind of object-oriented stuff, you're going to see so many instances or so many times the word self. And it can be, and if you're not familiar with how object-oriented programming works in Python, I know that, the first time I was exposed to Python object-oriented stuff, I was confused as far as why I kept seeing self everywhere. Okay, but this is how it works. Okay, so again, so that's what's going on when you see that. Okay, here we can take. I'm further developing the class definition of time. Okay, and so here we are going to pass create another method. Okay, and we're going to just ask if one time is after another time. Okay, so we're going to create a method inside the time definition, inside the time class time definition, called isAfter. And we're going to add this at the end of our definition. And basically what it's going to do is it's going to compare the times. Okay, now one thing you can do is if you're going to have, so isAfter, the way we're going to call it is we've got a time object. We're going to do time dot isAfter dot some other time object. Okay, and when you do that, Python is able to invoke methods that belong to that other instance, right? And so by convention, if you're going to use another instance of the same class, in our case, other, okay, by convention, we name this thing other. So you have self and you have other, right? And it kind of makes sense in all of this kind of this personal relationship thing, right? You have myself and you have the other person, okay? And what we're going to do is on the self, we're going to invoke time to integer, okay, which is fine. This is part of the definition of the class time, okay? And as far as the other is also a time class object. So we can also invoke the method time to int in the other instance of the time. Okay, so we can do other and do dot time to int, and we can compare that to self dot time to int. And this comparison is either going to return true or false. And that's what this method is going to return. So we do define isAfter. And if it's greater than the other, then it'll return true. And if it's less than the other or equal to the other, it's going to return false. Okay. So we can just call this. So here's 9:45. Okay. Here's another time. We're going to create the end time, which is going to be, we're going to increment the current time. And then we're going to say, is the end 10:07:17 after the start? End is after start. So start is 9:45, end is this, and that returns true. Okay, and we can, if we flip it around and we say is start after the end, start is after end, we get false. Okay, and this also follows the good naming conventions, where anytime you see a method called isAfter or anything that has an is or something like that, it by convention, we expect those things to return true or false values because they're kind of like yes or no questions. Is it after, another time, yes or no? And it's going to return kind of a true or false. Okay. So one thing we can do is we can create something called the initialize method. Okay. There's a special method called init, which is what we use to initialize. And that's because every time I've created, I redefine the object. And every time I do this, I do start equals time. And then I have to do start.hour equals 9, start.minute equals 45, start.second equals 0. Okay. It's a little bit, annoying, a little tedious to have to do this every single time. And so what we're going to do is we're going to use a special method called init. Okay, and this is it's because it's a special method. We call this double under. So there's a certain class, or not class, certain number of special kind of key methods that a lot of classes use, and these are often the double unders. Okay, and so you have double under init. You got a couple others that we'll take a look at. Okay, and so here, what this is going to do is this method double under init. All right, and so this is kind of like a special word, and anytime you use this special word, this is going to get executed automatically whenever you create a new object or a new instance of a particular class. Okay, and so usually what you do with the init method is you're going to assign values to attributes that get used in the class. So this is where we're going to initialize and assign values to the hour, minute, and second, so that it happens as soon as I kind of create the instance of the class, rather than having to kind of create the instance of the class and then after the fact say start.hour, start.minute, start.second, and do that, right? And then this just leaves us open to mistakes. For example, if I did start.seconds and I had a plural s, second s, plural of seconds here, then everything would break because my attribute is named incorrectly. All right, and so the init, it's a good idea to use the init method, and I only bring it up here after I've introduced kind of all of these other methods, just so that it kind of makes sense. But now that we're going to define the init, it should be fine. Okay, and so here we're going to define class time. Convention is you put init as one of kind of the first methods here. And so we're going to have define init. And again, self is always going to be the first argument. Okay, self argument. And then we've got hour, minute, second. And so by default, we're going to assign 0, 0, 0, hour, minute, and second to be these things. These are positional, so we don't always have to do hour equals 9, minute equals 45, second equals 0 or whatever. We can just do 9, 45, 0 or whatever we want. And then we'll take the hour and we'll assign it to self.hour. We'll take the minute and assign it to self.minute, and we'll take the second and assign it to self.second. Okay, everything else about the class definition remains the same from what we saw earlier. Okay, and so now when I create a new instance of the time class object, it's a lot easier, right? So I can just take time and do this, and that's going to take the default values of 0, 0, 0. I can say midnight.print time is going to be 0, 0, 0. Here, if I do time 9, okay, the first argument, other than self, I guess the first argument after self, which is really the first one that we can pass values to, is the hour argument. So we can do new time is time 9, and that will be 9 o'clock. So new time.print time comes back 9 o'clock. And then if I want to do 9:45, I can do time 9, 45. This is my new time, and that's going to be 9:45. All right. How does that feel? Feels good? It's kind of a lot. I am showing you a lot. Thank you for that thumbs up. But hopefully I'm building up, we're building up how these object-oriented stuff works in kind of this form that makes sense. Okay, let me give you your second view quiz answer. Second view quiz answer for today is D. D as in dog. D as in dog is your second view quiz answer. Okay. So we have this 9:45. All right. Now, this is another important method. And this is double under str. Double under str, and double under string. Okay. This is a special method. And what it does is it returns a string representation of an object. Okay. So far, every time we wanted to see the time printed out in this form, we've been calling new time dot print time, right? Because inside our class definition, we have this method called print underscore time. Okay. What we're going to do now is we're going to kind of replace that. So we don't have to keep calling print time. We're going to replace that with a double under string. Okay, double under string. And what this will do is that whenever you call print in Python, when you say print and you give an object to print, what it does is Python tries to invoke the string method, okay? It tries to invoke the double understring method, okay? And so what we're gonna do is we're gonna just kind of change this, rename this into the double understring method. And now we can just call print on the object, the time object. And when we call print on it, or we need any kind of string representation. So, if you do string on, some number or something, it kind of converts the number into a string form. Basically, it does that, and it's going to do that. So let me just kind of contrast this. So back here when we called print time is we created this string using kind of this this notation with the tuple, and then we called print on that. And so now we're going to create the string method, the double understring method. And this is how it is going to work. And instead of calling print, we're going to say return. Okay. So we're going to say return basically this string representation. So double understring self. So again, all of these methods, self is the first argument. We're going to say double understring self. And this is basically the same thing as the print time method. But what it's doing is it's going to return this string, okay, where the values have been filled in by the values in the tuple. Okay, and so now we're going to create a new time, and then we call print new time, and I think this makes a lot more sense than having to do new time dot print time or something like that. So now whenever you call print new time, it returns, it's going to output the string representation of this object. The string representation of this object. Is that good? I hope. Okay, so there's a this is where Python I think gets really cool. Is a lot of the object-oriented stuff have a bunch of these special double under methods, and so we'll take a look at a couple of these things. And there's a book out there that it's a little bit beyond the scope of our course, but there's this book called Fluent Python. You can actually read it. You can read it. How do I do this? Go to the okay. I don't want to get distracted, but pretty much you can read it in your browser from O'Reilly if you log in through the UCLA library. And I forget, let me see. Do I want this? No, I don't want to do this. Okay, well, there's a way to read stuff here. I got to remember. You log in through the library, and you put in your UCLA Bruin ID and stuff, and you can read pretty much all the books in the O'Reilly catalog. You're already paying for it through your tuition, so take advantage of it. Okay, but anyway, there's something called operator overloading, and this is a fancy name, but basically these things are going to get invoked. So double under add gets invoked anytime you use the plus operator. Okay, so you can take objects that are not, we're used to using the plus operator only for like integers and floats and things like that. I guess strings will concatenate strings and things like that, but you can take some kind of object like the time class object, and you can invoke the this operator whenever you do plus. Okay, and so one thing we can do is we can take one instance of time and another instance of time, and we can add those two things together. And so the way this is going to work is we're going to add this to the class definition, where we're going to do double under add. Okay, we're going to take itself, we're going to convert that to an integer in the number of seconds after midnight. We're going to take the other time, convert that to the number of integers after midnight. Okay, so we're going to do self dot to time to integer, other dot time to integer. We're going to add those things together. Okay, and we're going to add that. What is this? This should just be seconds is equal. I don't know why this is plus equals. This should just be equals, I believe. And then we're going to return that new time here. Okay. So so here, sorry, this is a typo. There's a plus equals. It should just be equals. Okay. And I have it correct here. I have it correct here. I just have a typo on this thing. Okay. So we're going to call double under add. This is going to get invoked anytime we use the plus operator. It's going to take the current time of itself, some other thing here, and then it's going to add them together. All right. And this will get invoked anytime it sees the plus, and the value in front of the plus will be the self. The value after the plus will be the other. Okay. So if you think about calling plus, you think of it like it's doing 3 plus 5 or something like that, right? What you can think of this is it's going to do the method 3, the thing dot add, and then it's calling 5. And so basically, whenever you have the plus operator, the value in front of the plus will be the self. The value after the plus will be the other. Okay. So here we've got start is 9:45, duration is 1:35, and here I can do start is going to be 9:45 plus the duration, which is 1:35, an hour and 35. We add those two together, and we can say, well, okay, print that out, and it gives me back 11:20. Yeah. So that's pretty neat, right? So we're invoking by calling the plus here, that invokes the double under add. Okay. 9:45 is the self, 1:35 is the other, and we're adding those two together here. And this is going to be the end time, 11:20. Is that okay? Does that kind of make sense? All right. This so, and now we're going to get further complicated here, even more complicated, right? So right now, with our current definition of add, we're taking one time object and adding another time object, okay? What we might want to do is we might want to be able to do, we can say, take the current time object and add another time object, like an hour 35, or we can say, take the current time object and add 60 seconds to it, okay? And it would be nice if our class was able to kind of figure out whether it should do this thing where it's going to convert things to the number of seconds and add them together. If it sees the thing, so if you have a current time plus another time object, it will invoke this method, add time. And then if it sees that the object that you're adding is just an integer, maybe it'll increment it. Okay, so it would be neat if you can define some kind of class definition that's kind of smart enough to recognize these different types, right? So here we're going to have we're going to do this, and we're going to use a type-based dispatch, okay, which is basically going to say, all right, so we've got this double under add, which is going to take a look at itself. It sees the plus, the thing after the plus, and we're going to ask, okay, the other thing, is that an instance of time? Okay, if it's a time instance, then we're going to call the add time method, which will convert the time instance into seconds and then add those two things together. Okay. On the other hand, if it's not a time object, we're going to just have to assume that it's a number, and then we're going to call self.increment. So we're going to call, depending on whether the other thing is time or not, we're either going to call add time if it is, or we're going to call increment if it's not. Okay, and if it's increment, we just take the self, convert that into a number of seconds, add that to whatever number of seconds it is. Okay, so the other gets passed in as the number of seconds, and then we're going to do that. Okay. Okay, so we have a question. It says, so the double under add method doesn't have to be defined after the other methods that it uses within the class. No, so the double under add method, so basically when you define methods and stuff, Python doesn't check to make sure that everything that you have here has already been defined. It can be defined, kind of in any order. And then and when you create an instance, all of those methods kind of get defined. And then only when you call the method, so you could have like code that totally breaks, and it's fine. You can create an instance of this thing, and the thing only breaks when you call the method that's actually broken, right? So you could have something that's like totally doesn't work at all, and the object could appear to be working fine, and it's only going to appear broken, or it's only going to return an error, an exception, when that particular method that is broken actually gets called or executed. So so all of these things, are fine. Okay, so here it is with add. We've got two definitions for adding time. We've got the add time and we have the increment. Okay, and then and we've created our kind of extended version of the plus operator add here. Okay, so I've got 9:45, duration is an hour 35. We can do start plus duration, that takes me to 11:20. Or I could say start plus, which is 9:45, add 13:37 seconds. Okay, and again, because of this plus operator has now been made a little bit more intelligent by handling the different instances or the different types, it can work and it doesn't break. So I think this is really cool. Okay, maybe I'm showing you too much and it can't be fully appreciated, but it's really cool. You can do all kinds of stuff, right? Okay, so here's one thing, right? If I try to do 1337 plus start, it breaks. It breaks because this is an integer and the integer doesn't know how to do, it doesn't know how to add time to itself, right? It says you can't do plus with integer and time, right? It's defined for time plus the integer, but it's not defined for the integer plus time, okay? So if you want to do something like this, there is a method called right-hand side add, okay? Right add. And basically if it sees the plus operator and it's going to say, well, oh, if you're on the right-hand side of the plus, right, 1337 plus a time object, we'll see if you can figure this out, right? And so we're going to do, we're going to define a method called right-hand side add, double under right add, and we got self other. And what it's going to do is we're going to, so on the right-hand add, the self start is going to be the self, and then the other is the thing in front of the plus. So normally self is the thing in front of the plus, but in right-hand add, the other is the thing in front of the plus, okay? And then this will work, okay? This will work, right-hand add. Okay, so we've got add, and then we're gonna do right-hand add, and basically right-hand add is just going to call left-hand add, but when it sees the order reversed, okay? And so I do this 9:45, 1:35, start and duration, that works fine. Start plus 1337, that works. And now I can do 1337 plus start, and that also works, okay? All right, yay. So these are examples of kind of, well, there's a whole nother thing called polymorphic functions. And so sum, basically, when you call sum, it's going to, when you call the function sum, it basically invokes the double under add, okay? When you invoke double under add, okay, when you call sum, it invokes the double under add operator here, okay? And so even though we haven't told Python exactly how to sum time, even though we haven't created like a special version of sum here, when we call sum, Python invokes the double under add, and then it says, oh, you know what? I can add these things together, and it does, okay? And so we can do, an hour 20, hour 30, hour 40, add all of those things up. That's 4.5 hours, okay? And it works, all right? So we'll end here, okay? Let me give you the last view quiz answer. Today's last view quiz answer is E. E as an elephant. E as an elephant. Okay. And the double understring, yeah, allows you to call the string function on it. And it's also what gets invoked anytime you call print. Anytime you call print, it invokes this double understring. Okay. There's a lot in this lecture. I would say work through the examples yourself. See if everything makes sense to you. And we will end here. And we will see you guys on Friday. All right. Have a good evening. We'll see you guys then.